Hi, welcome to Happy Friday. I'm going to spend some time going over the titrations homework sheet. I will also post the answers if you don't want to necessarily look at the whole video. I'm not going to go over every one of the questions, but I'll do 2 or 3 of them. And then the rest is basically a reminder that you've got a test due by noon and spiral that's due at 3:15. And just like a test day, we're not going to learn anything new yet. Monday we will go over a titration lab that is a virtual lab, and then we'll probably start the next unit, which is on organic chemistry on Tuesday. Okay, so the homework. I did the first one for you, and as long as you have the equation, the rest of it shouldn't be too bad. And remember that the equation is also in your CRT. It's on the very last sheet. And all you're really doing here is punching stuff in. It's not too bad. So let's take a look. I'm always going to put my equation first. MAVA MBVB. If it takes 25 milliliters of 0.05 mHCl to neutralize that, what is the concentration? I feel like I've already gone over this one, but that's okay. So, which is the acid, which is the base? Acids typically start with an H, hydrochloric, hydrobromic, hydrofluoric, hydroiodic. Bases almost always end with an OH, but not everything that ends with an OH is a base. You just have to be careful of that. So here's my acid, hydrochloric acid, and it tells me it has a molarity of 0.05. And it takes 25 milliliters to neutralize the base. What is the concentration of the NaOH solution? So I'm looking for MB, and it tells me it's 345 milliliters. It takes 25 mils of this acid to neutralize that. So basically, I'm going to bring this down here, multiply that by that, and divide it by that. And when you do that, you get a pretty low molarity of 0.004 molar. That's very, very weak. Okay? Typically, you'd think, by definition, bases, if you felt them, they are slippery. They tend to taste bitter. They're slippery. Other characteristics are they will turn phenolphthalein red instead of keeping it clear. But in this case, that's probably so weak that you might not even feel the slipperiness. Okay? Let's try number 3. If it takes 50 milliliters of 0.5 molar calcium hydroxide solution to completely neutralize 125 milliliters of sulfuric acid, what is the concentration? Same thing. MAVA equals MBVB. If it takes 50 milliliters of 0.5 molar calcium hydroxide, that is my base. So this is 0.5 molar, and it takes 50 milliliters. They're asking to neutralize 125, so I'm looking for the concentration of the acid. I solve for the molarity of the acid by multiplying these two and then dividing by this. This is actually going to come down here, and I get an answer of 0.2 molar. Okay? You're seeing it's the same thing essentially each time. I'll do one more. How many milliliters of that much molarity of H2SO4 are required to neutralize 25 milliliters of 0.1 molar of BaOH? Okay, is this a strong acid? Just to remind you, it is a strong acid. This is called sulfuric acid. And if the number of oxygens is greater than the number of hydrogens by at least by 2 or more, then it's considered a strong acid. How about barium hydroxide? Barium is in group 2. Remember, strong bases are going to be those that are made of groups 1 or group 2, not including hydrogen. So lithium hydroxide, sodium hydroxide, potassium, rubidium, beryllium, magnesium, calcium, strontium, barium, all of these are strong bases. That means that they will dissociate very easily in water and have that OH minus available. So how many milliliters of 0.36 molar sulfuric acid are required? So here I am, MAVA, MBVB. Neutralize 25 milliliters of 0.1 molar BaOH. 2. So here's my molarity of the acid, 0.360. And I'm looking for the volume. So that's what I'm solving for. Molarity of the base is 0.1. And the volume of the base is 25 milliliters. I'm solving for volume of acid. I multiply this by this and divide it by 0.36. And I get as an answer 6.944 milliliters. All right, I'm just going to write the answers for the other two. It's the same thing. That way I won't have to post the paper. Actually, I'll post it anyway. Number 5, the molarity of the acid is what's asked for, and that's going to be 0.16 molar. And number 6, the molarity of the acid is asked for again, and that's going to be 0.60 moles per liter. Just to remind you that moles per liter is molarity. Molarity is moles per liter. Okay? Okay, that's all I was going to do for today. On Monday, I will show you, have you look at and describe the titration lab that I found online. Okay? See you then.